Welcome to the Ecotechie. In today's video, we are slightly going to deviate from our normal. We are going to perform a challenge over here. Now, you would be wondering what exactly is this challenge? So, this is the challenge which was posted on Kaggle website. So, in this challenge, we have to use machine learning and predict from the Titanic dataset. We are all aware about Titanic, how that ship sunk because it hit an iceberg. We have all watched the movie also. Now, we are going to do something interesting. We are going to apply our machine learning models. We are going to do some exploratory data analysis on this Titanic dataset, and we are going to bring out amazing insights from this dataset. Now, without further ado, let's begin our Titanic challenge, which is hosted on Kaggle. At the end of this series of lectures, you will be ready with a submission that you can submit on the Kaggle website. It will be like a feather on your cap. You can show off to your friends when you are sitting for an interview, or you can show off to your colleagues, and the higher the accuracy that we achieve, the better it is. And let us see what kind of accuracy do we get in this Titanic dataset. So let's jumpstart into Titanic. Now, first and foremost, we have to import the necessary libraries. So this step is by now very clear for all. So our necessary libraries are import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, import cborn as sns, import warnings so that we do not get any warning messages in the middle. The pink boxes in the middle, we want to avoid them. Warnings dot filter warnings, we are going to ignore all the warnings. So let's write ignore. So these are our elementary libraries which are necessary for our machine learning model. Now let us import the dataset. I will provide the link for the dataset in the description below. I will also provide the competition details in the description below. So now let us import our dataset. df is equals to pd dot read underscore csv. So that's our data set. And we have to look at the head of the data set. Now let us run this code. So we have our passenger ID, we have survived, number of people, or whether the person with the particular passenger ID survived or not, P class, the cabin class, the name, the sex, the age, and sibling or spouse, whether the person is traveling with the sibling or whether the person is traveling with the spouse, parent and child, the ticket, the fare, cabin, and let's see what are left. The final is your embarked column. So this is our data set for Titanic. Now, before we go and apply all our machine learning models, it is important that we do some exploratory data analysis. In my previous video, I have explained how to perform exploratory data analysis like handling missing values, handling outliers, checking the info of the data set, the description of the data set, and so on and so forth. In this video, I will not cover all the exploratory data analysis because that will put a lot of pressure on us. So, I will just break this entire challenge into smaller parts so that it becomes easier for each one of us to understand and process what exactly is happening. So, now the first step is to understand the info of the dataset. So, we write tf.info. Now let us check the info of the data set. So we got our info of the data set. So passenger ID, it's a numerical column. So it's perfectly int. You can understand. Survived, you have 1 or 0. Again, it is an integer column. P class is again an integer. You have first class, second class, and third class. Name is an object column. Sex is an object column. But wait a minute. Age is a floating column, but why are there less number? All other columns have 891 and age only has 714. What does this symbolize? It symbolizes that there are some missing values in the data. Now, before we go ahead with handling it, I will tell you the three golden rules of handling missing values. So, the first rule is that if the missing values in your data set is less than 3%, you just drop it. So you use drop any. So if there are less than 3% missing values, we just use drop any. Use drop any. Now, it's not that in all your data set you will have it according to your wish, your missing values. Your missing values could range from 0 to 100%. Now, the second condition is that if your missing value is greater than 3% but less than 40%, that is a significant amount of it is missing. What will you do? You will replace it by using the fill any method. You can use mean, median, mode as per your convenience. So, if there are more than 3% missing values and less than 40% missing values, use the fill any method. So that's the second rule. Now, the third rule is that if in certain columns you have more than 40% missing values, what can you do? You can't go on filling it with me. It will definitely make your results wrong. What you just do to make your life easier, you just drop the column. So, if there are more than 40% missing values, just drop the column. Okay, so these are the golden rules of handling missing values, which every one of us should remember while performing exploratory data analysis. So, in age, if you see 714, it is not 3%, it is greater than 3%, but it's not 40%. So, it's somewhere around in middle of 20 to 30 or say 15 to 30%. So, what will you do over here? You will fill it up with mean value. Now, let us move ahead. So, sibling and spouse, whether the person is traveling with a sibling or a spouse, it is a numerical column. Parent and child is again a numerical column. It looks like there are no missing values in it. Ticket doesn't have any missing values. Fare doesn't have any missing value. But oh, look at cabin over here. It has only 204 non null values. What does that mean? Remaining is your missing value. Now, if you see 204 out of 891, roughly only 20% of your data is there. Remaining everything is missing. So, what will you do in such a scenario? You will use the third golden rule of handling missing values. That is, you are going to simply drop the column. Now, to check if whatever we have said over here is correct or not, regarding the percentage of missing values, we will just use df.isne.sum so that we get a sum of all the missing values in the different columns. So we have 177 missing values in each and 687 missing values in cabin. And lastly, embarked. Embarked has only two missing values. So what are we going to use? We are going to use the first golden rule of handling missing value. We are just going to drop the row which have missing values. So in this way, we understand missing values. We have got the logic of how to handle missing values. Now, let's deep dive into exploratory data analysis. Let us do the descriptive data analysis. Let's see what are the different descriptive statistics are. What is the mean, median, are there any outliers, so on and so forth. df dot describe. Now let us run this. Now look at this set of columns. Over here, for the fair class, the fair class has a mean of 32, has a standard deviation of 49, and there is a minimum value of 0. What does this imply? It implies that there are people like Jack on board of Titanic who are not paying anything to get on it. And then there are people like Rose, the ultra rich people, who are paying 512. These are just an assumptions about Jack and Rose, but this clearly shows that there are outliers in the fair data. Now, if there are outliers in the data, how do we come to know about it? It is pretty simple. We have to plot nothing but a histogram. A histogram will tell us the distribution. So df.fair.plot, we will give kind is equals to hist, so that we get a histogram. So we end up with a graph which looks something like this. Over here, you see that there are certain outliers. By just looking at this graph, can you tell me whether it is a skewed distribution or not? And what kind of skew? Is it right skewed or left skewed? So, by just looking at this, we know that the distribution is not normal. It is asymmetrical and it has a right tail. Now, you would be wondering how exactly I am coming up with this conclusion that it has a right tail. It's pretty simple. We are going to plot an SNS dist plot. A dist plot will show us the distribution of it. So, SNS dot dist plot df at TD, which stands for kernel density estimate, we will say that it is true. So now over here we get a clearer picture. It clearly states that you have all your values or your mean value at one point, but your mean is to the right of your mode, and you see that the tail is towards the right side. So we can clearly say that this is a right tailed distribution. So that was about the distribution. And if you want, you can handle these outliers. But let us keep it as it is for now. Let's go on and deep dive into another metrics, that is your correlation. So let us check for correlation between different values. df.core. Now let us run this. So over here, our target variable is nothing but whether the person survived or not. And all of the variables that you see, P class, age, sibling spouse, parent child, fair, so on and so forth, these are your independent variable. Now focus on the survived class. If you see, there is a very small correlation between passenger ID and survived. It clearly says that there is no much relation between passenger ID and survived. Now, survived with survived will have one as correlation. Now, there is a negative relationship between the P class and survived. So, as the P class increases, your survive rate falls. And again, there is a negative relationship between age and survived. Maybe this is because if you have watched the movie, they have given preference to women, and they have given preference to children when they were deboarding onto another small ship. So here you have negative relationship between the age and survived. And sib spouse, again you have a negative relationship. And parent child also has a very small positive relationship. But look at this. If you look at the fair and survived, it has a pretty high positive correlation. What does that imply? A person who has paid a higher fare has higher chance of surviving than a person who has paid a lesser fare. So, like this, we can make insights or draw insights on all the different columns with all the different columns. Now, this is easy for you and I, but it will not be pleasing to a person who is very new to programming. So, to make other people understand, to make our understanding more crystal clear to the entire population, we will just plot a heat map. A heat map will show the different degree of correlation between different values. So, SNS dot heat map bf dot core and n naught equals true. Now let us run this code. So here our heat map is ready. This is much easier to decipher because the lighter the shade, the higher the correlation. The darker the shade, the negative the correlation. So whenever you are presenting results in front of mass, or in front of the management, it is better to show them graphs instead of showing them tables, because it is easier to understand graphs over tables. So now we have just reached one fourth of our challenge. We have only deep dived into the exploratory data analysis, but EDA is not over here. We have to perform missing values, we have to handle the label encoding, that is we have to handle the categorical variables, and then we have to fit our model, we have to check for the accuracy score, and so on and so forth. So for today, let's give it a pause over here. I hope the exploratory data analysis is clear for one and all. Do like, share, and subscribe to the ecotechie, and please keep watching because we are going to have the next part